Hello, in this video I'm going to talk about how to find several probabilities, several joint probabilities, given a joint probability distribution function. And I've chosen this distribution function because of this dependent support, okay, where x depends on y. And I'm going to start with something, a joint probability that's rather easy, and we'll build up to ones that get quite challenging, okay? So, let me start by saying that I could have written this support slightly differently. I could have written this as -1 is less than or equal to y is less than x, right? This is the same thing as this. It's just written all in one statement, okay? I guess technically that's less than infinity, but it's kind of, it's kind of redundant. You don't need to have that piece, okay? So, all right, so first thing that you should start with when you're trying to calculate probabilities and you have complicated supports is drawing out your support, okay? So let us start with that. Let's draw our support. All right, so here's -1, here's -1, 1, 2, 3, 1, 2, 3. This is y and this is x. All right, so let's see. Starting with y is greater than -1. So here's y equaling -1. Greater than -1 would be up in this direction. Okay, x is greater than y. So let's draw where x equals y. Dotted line for that one. Okay. Here's x equals y, and if x must be greater than y, then it'd be upwards in this direction. Okay, so my support, basically this function takes non-zero values in this triangular area here, and it continues onwards to infinity. All right, so if I were to find the total probability, or if I were to integrate over all of this, I should get 1, and we did that in the previous video. Highly recommend that you start by watching that video. Okay, so total probability is 1 for this probability distribution function, and so now I'm trying to find probability of starting with x being less than 3 and y being more than 2. Okay, so I want to find the probability of this happening given this probability distribution function. Okay, so I know that what I'm going to have to do is integrate my joint probability distribution function with regards to x and y. The order of the integration does not matter. I'll do it both ways for this first one, and you can solve it both ways and see that it doesn't matter. You should get the same answer either way. Okay, so trick is knowing these bounds. Okay, so let's talk about how will we find these bounds. So we know x needs to be less than 3. So here is 3, x equaling 3. X needs to be less would mean I'd go to the left. Okay. Y needs to be greater than 2. Y needs to be greater than 2 would mean I'd go up. Okay. So this little triangular area that I'm marking here in red, this is where I want to integrate over. I want to integrate over this little tiny triangular area. Okay, so when I do my integration, first if I start with y, dy, then remember y goes up and down, okay? And your first integration, that's where you're going to want to take into consideration this dependent relationship. So I'd go from, looks like y starts at 2, and it goes all the way up until whatever x is. So 2 to whatever x is. Then when I'm integrating over x goes left and right. So x goes from 2 until 3. Okay. Now I shouldn't say x goes from y to 3, because if I do that, my final answer is going to involve y. Probabilities should be a number between 0 and 1. They should not include random variables. Okay. So my answer should be between 0 and 1, should not include y. If I have a answer, question is find a probability, and my answer includes a random variable, then I made a mistake. Okay, your answer should be a number between 0 and 1. Okay, so we talked about extensively in the previous video why I would not go from y to 3. I would go from 2 to 3 because this dependent relationship here, this was already taken into consideration in this first integration. Okay, So I would go entire range of x. X ranges from 2 to 3. Okay. All right. So there you go. That's my, I could solve that and find what this is. Just plug in this PDF here and then take the integral with regards to y, then take the integral with regards to x. Okay. I said I could have set it up with dx dy. So let's talk about how we would do that differently. So first, integrating with regards to x moves in this direction. Your first integral, you want to take into consideration this dependent relationship. Okay, so I would go from, looks like I go from integrating with regards to x, so x equals y to x equals 3. X equals y to x equals 3. So x equals y to x equals 3. Okay, and then for integrating over y, total range of y goes from 2 until 3. All right, if you solve both of these, you get the same answer. Go ahead and try to do that on your own. If you need help with integration, just let me know, and I could possibly do another video where I actually solve this out. But that would take a lot of time because I want to talk more about how to set these up than how to actually solve them right now. Okay, so now let's set up this next one. So this next one, it's very similar. All right, I still have x being less than 3, so still over here. But now what's changed is y has to be less than 2. So that means my area now is changed to this down here area. Okay. I had a student once ask me, well, can I just do this is 1 minus this? And the problem with that is you still have all this area over here. Remember, x goes all onwards to infinity, and so you still have all this area over here. So this plus this, these two probabilities don't necessarily add up. They don't add up to 1, okay? Because you still have all this area over here that you're not taking into consideration. Okay, so don't do that. All right, so I want to figure out what this down here is. Okay, so let's see. Let's go ahead and write this out. So I want to do my integral. Say I want to go dy dx. So starting with integrating over y. Now y goes from -1 until x. Until right here. Oh no. It doesn't follow that rule anymore. Y goes from -1 until it gets stuck, right? It gets stuck at 2. So I want to, because of this is kind of an odd shape. And when I'm doing this integral, I don't just have a triangle. So I want to split this up into 2 different shapes. That should be cutting through at 2. Okay. So I want to split this up. So now I have a triangle, and then here I have a square or a rectangle. And because of the addition rule for integration, I can integrate over this area, and I can add that to the integral over this area, and that'll be the total. That's the same as the integral over this total area. Okay, so you would definitely want to take advantage of that properties of addition for integration. Okay. So let me go ahead and write this out. So let's see, I'm going to want to split it up. So first, starting with this area right here. Okay, so where does y go from? Starting with, I have dy first. So remember, y goes up and down. So y goes from -1 until x. So y equals -1 to y equals x. Okay, then if I go over x, x goes this way. So x then would go from totally from -1 until we get to 2. Okay, so that would be this area here. Remember, x doesn't go from y to 2 because we've already taken into consideration that x is more than y in this first piece here. So we want to add that. We'd want to add this to the second piece over here. dy dx. Okay, so integrating over y goes up and down. So -1 until I get to 2. Okay, x goes horizontally. So it goes from 2 until 3. X equals 2 to x equals 3. Okay? If you add up these integrals, you should get that probability. Should be a number between 0 and 1. All right. Let me go ahead and change this up a little bit. Let's talk about, make it a little bit more difficult, how to find the probability x is greater than 1 and y is less than 3. Okay. Always start by drawing your original support. 1, 2, 3, 1, 2, 3. All right. Okay, so this yellow area, that's my original support. Okay, so now my probability, I need to have x greater than 1. So here's x equaling 1. X greater would be over here. Okay, and y needs to be less than 3. So here's y, 3. So I still need to be in the yellow area, so down here, right? Less than 3. All right. So this red area, this is now where I am. Okay. So let's see. And it goes onwards to infinity, right? This is quite a difficult shape. So let's see if we can figure this out. All right. So I know I need to be doing an integral. Let us do, let's go ahead and do y first and then x. Probably going to have to split this one up too into several different shapes. Okay, so let's see what we can do. If I go with y first, so moving in this direction, so I go from -1 all the way until I get to x. Remember, this is x equals y. So -1 all the way up until I get to x. But again, that relationship breaks here. Okay, and don't go from -1 all the way up into x once I get here. So I'm going to split this into 2 different pieces as well. Okay, I'll integrate over this piece first. So I'll go from -1 until I get to x. All right, so that right now I'm doing this piece. Okay, so where does x travel from? In this little piece, x goes from 1 to 3. It goes from 1 to 3. All right. So then I need to add this. I need to find the integral of this second piece over here. Okay. dy dx. Okay. So for the second piece, let's see, where does y travel from? Y goes from -1 until 3. And then where does x go? X goes from 3 onwards to infinity. All right. If you add up these integrals, you should get the probability. It should be a number between 0 and 1. Okay. Let me go ahead and do one more. Say I want to find the probability that x is greater than 1 and y is greater than 3. Always start with drawing your original support. Okay, so -1, -1, 1, 2, 3, 1, 2, 3. Okay, so this is my original support down here. Okay, so x is greater than greater than 1. So here's x equaling 1. Greater than would be over here. And y is greater than 3. So where's 3? 3 is up here. Okay, so x is greater than -1, so it's over here, and y is more than 3. Now, the fact that x is greater than 1 is taken care of up here. Right, up here, y is greater than 3 in this area, and x is more than 1. The fact that x is more than 1 is kind of irrelevant because, remember, x must be more than whatever y is, right? That was in the original support. X is more than y. So x is more than y up here in this little triangle, okay? So really, this is kind of irrelevant, right? But this is a joint probability because this piece is included in the probability, okay? So we're still going to be using the joint probability distribution function, all right? So this is equal to we want to integrate this little red piece here, okay? So where does y travel from? If I'm integrating with regards to y first, y goes from 3 onwards to x. 3 to x. Okay? 3 to x. And then where does x go? X goes from 3, remember this is 3, all the way to infinity. All right? So you can go ahead and put in the probability distribution function and you can solve for this.